What this little video is going to do is I'm going to show you how to count combinations of 2. Combinations of 2. Combinations is a fancy math word that has a very specific meaning, and it kind of means group. Group of 2. Now, here's 2. These are 2 brothers. This is Alvin.
Hello, Gordon.
This is Simon. We have 2 brothers. We have 2 to begin with. In math speak, we have a pool of 2 objects. Okay, we have a pool of 2 objects. We're going to grab 2 of them. How many ways can you do this? The answer is 1, because look, there they are. I got 2. Whoops, sorry, Alvin. We got 2. That's it. Notice that when I say I'm grouping 2, I don't mean Alvin and Simon is 1, and then, whoops, Simon and Alvin's a different one. No, it's the same donut committee, right? It's the same 2 people going to the store. So, when I say groups or combinations, order doesn't matter. There's only one group of 2 here. Now, believe it or not, there's an official notation that we use for this group of 2, and we go like this. We say, okay, I had 2 brothers, put a 2 here, and I was trying to form a group of, so we put a big C like this for combination, a group of 2 brothers. 2 choose 2. That's what the C is kind of for, combination or choose. I had 2 brothers. I wanted to choose 2 to go to the store. How many ways can I do this? There's only one way, as we saw. 2 choose 2 is 1. Okay, it's just a notation. Now, why do we have such a notation? We have such a notation because sometimes we're going to have more than 2 brothers. Like, let's bring in Theodore. Okay, so now we got 3 brothers. 3 brothers. How many ways can we choose 2 of them to go to the store and get donuts? Our donut committee. And, well, let's see. We already had this group, right? This was before. That was the one group. And now look at this. Now that I have a Theodore, I got one group, and I might just, substitute Theodore for Alvin. There's another group. Or I might substitute Theodore for Simon, and there's another group. So in other words, I've got 3 possible groups. Either these 2, or these 2. 3 possible groups. Now, on the math speak, we would say that we had 3 brothers, and we were choosing 2 to go to the store. Okay, and what did we get for an answer? Well, I'm going to write it, I want to show a pattern here. We had the one group originally, Alvin and Simon, and then when we brought Theodore in, that allowed us to do 2 substitutions to make more groups, right? We could either substitute them with this or substitute them with this. So we had 2 more possibilities, and that got us to a 3. 3 brothers, choose 2 to go to the store and get donuts. You can do that 3 different ways. You can either choose Alvin and Simon, Alvin and Theodore, Simon and Theodore. Okay? So 3 choose 2 is 3. Again, order doesn't matter here. Now what happens if we bring in another chipmunk? This one's called Jeanette. Okay, I got 4 chipmunks. We want to choose 2 to go to the store. How many ways can this be done? Well, let's put these 3 guys over here. Now remember that we figured out there were 3 ways to choose a committee of 2 from these guys, right? When we had just the 3 brothers, we came up with 3 ways to pair them up. Well, now that we have Jeanette, notice we can make 3 more substitutions to get 3 more possibilities. We can either replace Jeanette with Alvin. How do you like that? Or we could replace Jeanette with Simon. There's another one. Or we could replace Jeanette with Theodore. That's what happens when you pick them up by the head. Anyway, 3 more possibilities. So on our little math chart here, the pattern we're coming up with is if we have 4 chipmunks and we're choosing 2 to go to the store, we can do that how many ways? Well, we had 3 more possibilities because Jeanette could substitute for any of these 3 people. 1 plus 2 plus 3 is giving me a 6. Now I'm running out of chipmunks, but I think you get the idea. That's what I wrote, by the way. 4 choose 2. 1 plus 2 plus 3 plus 6. Okay, let's pretend we had a 5th chipmunk, because I think we can figure out the pattern here. If we had a 5th chipmunk, we would still have all of these possibilities, the 6 possibilities from before. But since we have a 5th chipmunk, just imagine it's there, a 5th chipmunk, we could make 1, 2, 3, 4 substitutions to get 4 more possibilities. So, 5 choose 2. 4 more possibilities. 1 plus 2 plus 3 plus 4 is 10. Okay. Now, I don't think I need another chipmunk for you to figure out the pattern. We've just figured out the pattern. You got a certain number of objects, 6 of them. You're going to choose 2 of them, and again, order doesn't matter. You're just going to group 2 of them to go to the store and get donuts. How many ways can this be done? Well, 1 plus 2 plus 3 plus 4 plus 5 would give me 15, and so on. Okay. This is counting combinations of 2.